Hello students, welcome back. We are discussing the Laplace transform, and we saw two examples in the previous lecture, how to find out the Laplace of a given signal and the ROC. In the today's lecture, we'll take some more examples. We started with in the last lecture, finding out the Laplace of e power of at, and we found that the solution was equal to 1 over s minus a. And we also saw the ROC was the real part of the s is greater than a. So let's say now modify this signal and say that you want to find out the Laplace of e power of minus at. We'll go with the same methodology, that is, assuming that this signal is a one-sided signal u of t, then you can take this as 0 to infinity of e power of minus at dot e power of minus st dt, and you can easily solve it as 0 to infinity of e power of minus s plus at into dt. The solution, when you find out, the solution of this will be equal to 1 over s plus a. When you solve this e power of minus s plus at by minus s plus a and take the limits from 0 to infinity, the solution is this. So this is the Laplace transform of the u of t, Laplace transform of e power of minus at. So the ROC in this case, as you know, the ROC in this case is nothing but, when you solve this, you said that e power of minus s plus at with the limit t tending to 0, tending to infinity, with the limit t tending to infinity should be equal to 0. And when is it possible? It is possible when s plus a assumes the positive values. S plus a assumes the positive values, so greater than 0, or say the real part of the S is greater than minus real part of the A. So this is the ROC. So this means your the region of convergence will be, suppose if you say this is your minus A, so region of convergence will be greater than, this side will be lesser than, and this side will be the greater than minus A. Similarly, let's take one more example. Suppose you are given how to find out the Laplace transform of a unit ramp function. A unit ramp function can be written as a u of t. So this can be the Laplace transform of this will be written as equal to 0 to infinity of t into e power of minus st dt. And I know that t terms are in both the e power of minus st and t as well. So you need to solve it by parts. And when you solve it by part and substitute the limit, the answer to this will be equal to 1 by s square. I would expect that you solve it yourself and find out how this comes. This is integration by part. So you can solve it using integration by parts. So once you solve this, so that will be the solution for it. And then you can find out what is the ROC. So the ROC in that case so to find out the ROC of you will find out that this is possible when real part of S is greater than 0. Why? Because the top it will be e power of minus st with t tending to infinity. So it is because e power of minus st is equal to 0, and this is possible only when s takes on the real values which are greater than 0. The real part of s takes on greater values positive side. It takes on values greater than 0. So well, fine. That's all in this lecture. We'll see some more examples in the next class.